We have the steam at point number 1. It is at 500 kPa and 250 degrees Celsius. When the steam expands isentropically, it means that the entropy does not change. Entropy at 1 is equal to entropy at 2. In other words, entropy at 500 kPa is the same as entropy at 70 kPa. So now I'm going to go to a Mollier diagram, and then we are going to locate 500 kPa and 70 kPa. Mollier diagram. Right, so here is a Mollier diagram. The steam expands from 500 to 70 kPa. Go to the Mollier diagram and then locate 500 kPa line and then draw a line. Here is 500. You draw a line. On 500. That is your first pressure before the steam expanded. Now it expands to 70 kPa. Locate your 70 kPa line. This is 50 kPa. This is 60 kPa. This is 70 kPa. So draw a line on the 70 kPa line, 70K graph, maybe up to there. So now we have two pressures. Now we need to determine the first point. The first point is point number 1, the steam at 500 and 250 degrees Celsius. So you locate your temperature. Your temperature, 250 is here. 250 is not here, guys. It is not here. It is the line below 250. This is 250. So you draw a line until it intersects with your, there we go. So we have point number 1. This is the steam before expansion. Where your 250 degrees Celsius line cuts or intersects with your 500 kPa, this is your point number 1. Now we are told that the steam expands isentropically. Isentropically, it means that the entropy at 1 and entropy at 2 is the same. So you take your ruler. Remember the vertical lines. These vertical lines are entropy. So you draw a straight line from 1 up to where it cuts a 70 kPa line. You draw a line up to this point. So this is where it cuts your 70 kPa. So the process between 1 and 2 is isentropic process. Entropy is constant. So entropy at 1 is equal to entropy at 2. So the question says, determine the dryness fraction. So from here, you can follow the line, that line, the dryness fraction line, up to here. So here we have 0.9, 91, 92, 93, 94, 95, 96, 97. So according to the information given, the dryness fraction when the steam expands from 500 and 250 to 70 is 0.97. And then we go back to our question and check if the answer is correct. Here is 0.97. Some of you will say 0.96. I still give you the answer because it's very close. I don't know if you want me to repeat this question, but I'm going to repeat it. Question number 10. The steam, when it expands from point 1 to point 2. And by doing so, when it expands, the pressure drops and the temperature drops as well. So in our case, the steam is at 500 kPa and the temperature is 250. In other words, the steam is superheated. Now, superheated, now it expands. When it expands, it becomes wet and the pressure drops to 70. Now, we use the Mollier diagram to determine the dryness fraction of steam. In other words, we use HS diagram in order to determine X of that particular steam. So to answer this question now, I said we go to HS diagram, which is the Mollier diagram. Don't forget that the vertical lines represent specific entropy. So I said the word isentropic, it means that the entropy is constant. So Entropy at this point here. Entropy at this point, along this line here, entropy is constant throughout. So on the vertical lines, the entropy is constant. So I said that to attempt this question, we first locate and draw a line on 500 kPa pressure. So 500 kPa, here is our 500 kPa line. You draw a line because we don't know where the temperature line is going to be. Right? And then you locate the pressure after expansion, which is 70 kPa. 70 kPa, you have 50 here, you got 60 there, and then here is 70. You draw a line, 70 kPa line. Right, now we have two lines. Now we determine the first point of steam before expansion at 500 kPa and 250 degrees Celsius. So 250, I said that 250 is here. It is not where you see 250. The line below 250 is where 250 is. And then you draw a line. When that line cuts or intersects your pressure 1, this is your point number 1. This is where we are. Now this steam expands isentropically or at constant entropy. Constant entropy, it means that you have a vertical line. From that point, take a ruler. So this is where we are. Point number 2. Now the question says calculate the dryness fraction. So we can get two things here. We can calculate, we can get enthalpy, so specific enthalpy, which is, but the question didn't, I'm just making an example. The question never asked for enthalpy. Our enthalpy at that point is 2560. And then dryness fraction, I said we'll follow that line. So this is 0.5, this is 0.95, 96, and 97. So X is 0.97. So two properties that we can find. The first one, those properties, is enthalpy, 2650, and dryness fraction, which is 0.97. Simple as that. So in the exam, I might give you a question like this and ask you to calculate either temperature, enthalpy, or dryness fraction. So please, guys, understand how to use the Mollier diagram. Okay. Now we go to the second question. The second question says, question number 11. The question number 11 says steam is at 1400 kPa and 216 degrees Celsius. It expands isentropically to a pressure of 100 kPa. This is similar to question 10. The difference here is that for question 11, we don't use a Mollier diagram, we use the steam tables. The question says, calculate the dryness fraction of steam after expansion if Cp of steam is 2.11 kilojoules per kilogram. Calculate the dryness fraction of steam. So I'm going to open a new document here. Control N. Right. So we will say that entropy, which is S, entropy before expansion is equal to entropy after expansion. S1 is equal to S2. Now S1, the steam is superheated, so we can say that S1 is S2. Specific entropy of superheated steam is equal to specific entropy at 2. The steam is wet, so we can say that the specific entropy of superheated steam is equal to the specific entropy of wet steam. Now here, we can apply the formula. Remember, we are looking for X. This is what we are looking for. So what is the formula for S soup? S soup we can still go back to the formula sheet. Where is your formula sheet? The formula sheet is here, where S soup is equal to SG plus CP ln of TF minus T soup. Where are we now? We are here. So you can scroll up, and then you get your S soup. Here is your S soup. Here is your S soup. S soup. And then we can say that S soup is equal to SG plus CP ln of T soup over TS is equal to, now at which pressure? At P1. P1. In our case, P1 is 1400. 1400 kPa. S wet is SF plus X SFG. At which pressure? At P2. And in this case, what is our P2? Our P2 is okay. Our P2 is 100 kPa. 100 kPa. At 100 kPa. So what we can do now, we have to go to the steam tables. We get SG, we get TS at 1400, and then we go to the steam tables again. We get SF, we get SFG, and 100 kPa. So we have everything. We have everything. So SG at 1400. We go to the tables. SG at 1400. Where is here is 1400. Here is 1400. 1400. And then SG is here. $6.4 4675. 4675. We say SG 6.4675. CP is giving us 2.11. 2.11. And then ln of, where is the T soup? T soup is 216. Now 216, ladies and gentlemen, because this is entropy, we have to add 273 because entropy is in Kelvin, not in degrees Celsius. So you say 216 plus 273. 216 plus 273. 489. 489. Now, let's see what happens if you forget to add or to convert degrees Celsius to Kelvin and see what happens. You can do that on your own and see if you get the same answer. But for now, the T soup is 489 after converting it to Kelvin. 489. 489 divided by, now we want TS at 1400, saturation temperature at 1400. We go to steam tables. 1400 TS is 195.04. We are here. 195.04 plus 273. 468. 468.04 is equal to, now we are going back to the steam tables. We want SF at 100 kPa. SF at 100 kPa. We scroll up to 100. Where is 100? Here is 100. SF is 1.5 1.3028. 1.3028. 1.3028 plus X SFG. Go back to the table. At 100, it is SFG is 0562. 0562. So now we have only one unknown, and that unknown is X. And then when you punch in your calculator, you should be able to get what? You should be able to get, let me check, to save time. I'm not going to. To save time here, I think the answer is 0, X. You can also confirm from your side. If you get a different answer, you tell me. From this, I get 0.868. I would prefer it 0.868, but now the answer from the third, they say is 0.87, which is also correct, but I always prefer our answer to be in 3 decimal places.